So you think they used forks first in the garden or in the kitchen?
Hey, this is Julius, and today I'm making forks. Let's go!
I always wanted a titanium fork. I don't know why, maybe it's a boys thing, maybe it's a me thing, and now I'm making it. And while at it, I might as well make it fancy. I need a catchphrase like dress to impress, model to... what? Okay, no. Design to resign, definitely not. Sketch to overstretch. Oh man, this feels ominous. Sketch to overstretch it is. I will be designing a titanium 3D printable fork using solid bodies modeling. If you're not into CAD design, skip to this timestamp. For the rest of us nerds, this will by no means be a tutorial. I like to identify as a motivator, not an educator, but I'll showcase some techniques just to try to inspire someone in creating their own stuff. Let's go! First of all, I need some ballpark for dimensions and shapes, so I took those pictures from a distance, trying to keep the perspective to a minimum. Then I replaced the background for better contrast. Load and calibrate. Go for the largest dimensions because the measurement error will be less significant. I need a starting point, and the tips are the simplest part. Also, I think I remember some advice to always start at the tip, but I can't remember the context. Anyway, did you ever try to pick something up with a fork and it just keeps falling out? How annoying is that? So I'm designing some hooks on the tips. We'll see if this works. Me from the future, it didn't. I don't want to design this 4 times. So instead, I'm making a new body that I can rectangular pattern across for all of them. Then simply apply combine on each of them. Rectangular pattern is always your friend. Okay, my aesthetic concept is to extend the 4 prongs into the body of the fork. Something along these lines, pun intended. The proper tool for that is the sweep. But I'll be honest here, this time it humbled me. First I drew some spline that follows the shape of the fork. Then I copied that to the side and reshaped it into a guardrail in 3D sketching.
It was at this moment that he knew.
If I were to do it again, I'd compose the shape out of better defined arcs and lines. Anyway, after just countless adjustments, the sweep finally accepted my domination and it built me this. Beautiful. It looks amazing like that, but those prongs do need to stay together. So I built some hexagonal extrusions that should stabilize the heel of the fork. But I need to trim them to size, and for that I'll use the sweeping splines that I worked very hard for. All I need to do is sweep a sort of sheath that encapsulates the body of the fork. I'll then use this to subtract unwanted parts from everything that I want to add to this fork body. Neat. Here's a little teaser of what comes next. In the meanwhile, I'll cleared up some space in the handle, which I then filled with a solid body. I want to have a slight overlap at the boundary between this body and the fork, so I'm offsetting all the edges. That's pretty basic stuff. Let's export this as an STL and move into Blender, because I found a really cool trick that I want to share. I found this free TPMS generator plugin, which is insanely cool. Again, this is not a tutorial, but I'll leave the whole process for this part because I haven't seen this before and I should have. This is very underrated. The plugin offers a bunch of options for patterns. I went with the gyroid, well, first of all because it's the poster boy of 3D printing and it looks cool, but also because I'm certain it will print okay. It's essential that I don't move the solid placeholder. Stop hoarding the place. It's essential that I don't move the solid placeholder. This way, when I export back into Fusion, the result will just drop in place directly, already properly positioned. I'm building a large enough box just to encapsulate all the body, overlap them, and add a Boolean modifier to intersect them. I don't really like the stray pieces at the tip, so I'll just move the TPMS around a bit. rotate for a bit of a better match. I like this, so I'll take it back and see the result. That is gorgeous and you can't convince me otherwise. You can see now why offsetting edges was needed beforehand. I wouldn't wanted to deal with that intersection. I'm really happy with how this turned out. One last detail needed, adding the logo in the handle. Okay, last tweak, trimming away some fat from the heel for both looks and cost. Sketched over stretch after all. Well, now we get to the exciting part, turning this from a computer file to a solid object in the real world. And for this I really need to thank PCBWay, the facilitators, for sponsoring this video. It's truly amazing what you can do nowadays, which was literally impossible for a random guy like myself 10 years ago. So grateful to be living in this age. I upload my STL, so eager right now. Aluminium would be very reasonably priced, but it needs to be titanium. Okay, needs to be titanium. After some feedback from their engineers, I fixed issues in my model and my order went into production. Let's do the unboxing. Meet my trusty unboxing helper. That's a good girl. This is so cool, by the way. Look at this. It's so flexy. Super flexy. Without bending though. Super elastic. I didn't know what to expect because, yeah, I'm not playing with titanium every day. So this is so light, by the way. This is much better than I expected. Quick weight comparison. It's lighter than my kid's fork. It has a powdery finish specific to the powder melted with laser type of 3D printing. I quite like it, but it's not right for eating with probably. So I'll need to give it a bit of a polish. Yeah, this is not gonna work. I'll probably need to take the jewelry maker's route. Side project! I'll build myself a tumbler. But let's put a pin in that because I have some other forks planned. A fork in the plot, you might say. For this I'm making a silicone mold from a 3D print, coarsely resembling a fork. I'm trying to give myself a chance of being able to release something soft or brittle from it. How cool would it be to have a fork made of salt, so you won't salt the food, you can just suck on the fork, right? Still with me? I thought we're in this together. The setup is simple, a silent fan circulating warm air on top of the radiator. I discovered that this rude behavior called salt creep is a thing. Salt is pretty nasty. Yeah, it's a better escape than half the prison break seasons. It didn't survive the unmolding, but it came out much better than I expected, to be honest. Pretty cool. It's sure worth another more involved try in the future. It kinda looks like an artifact from a pharaoh's tomb. The print lines are also cool on salt. Back to the Tumbler. The plan is to make a very crude one, not spend too much time on it, and I think I'll try to abuse my drill for this. I sort of low-key hate it because the chuck is not very true. Works like a well-oiled charm. The jar also seems right, definitely a great proof of concept. But the drill stops after a few minutes. Nothing is heating up, so it must be a timer or something. I could use a classic windshield wiper motor. Nah, definitely no timer on this one. But that smoke. What else should I abuse next? If I only had a wiper motor. Stepper motor it is! But I don't have a way of coupling these two shafts. That doesn't make the whole thing look Sovietic. That ship has sailed, that ship has, it's sunk, it's on the bottom of the... Too small and flimsy, let's see its bigger cousin. I'm pretty sure the bottleneck now is the easy driver. Should I get a wiper motor or try the big boy's driver? Still borderline too weak. Just get the Okay, I'll try the wiper motor. I just hope it's not too fast. If it needs reduction, I'm gonna flip this table. What do you know? It works. I'll try some sandless media because I don't know what I'm doing. And also I promise to do a better cooling job on the second wiper motor. Meanwhile, I read some more and they seem to use this type of cylinders. I don't want to wait for the delivery, so I'll just use nails. Hopefully it works. Very loud, but mesmerizing. Anyway, 11 cumulated hours of on and on tumbling later, this is the comparison. It did smooth out the powdery finish, so I'll call it a success. Now for the final battle. Meet the Gummy fork. Who do you think is gonna win? Who do you think is gonna win? Who do you think is gonna... Oh. That was... that's a knockout. Thank you for watching. I'm working on a bunch of crazy projects right now, so if you want to stick with me, go ahead and subscribe. Catch you in the next one. Catch you in the next one.